Artificial intelligence is deeply embedded in our lives. Most of the time, we are not aware that we are interacting with it at all. What used to be considered artificial intelligence is now just routine, one tool among many hidden in our infrastructure, occasionally spotlighted for marketing or interface purposes. While most AI focused on analytics, decision-making, and processing, today AI can autonomously create new media, voices like this one, sounds, images, videos, music, and text. This video is about technology that is still in its infancy, as this AI takes a text as input and generates an image from it. AI is developing at a dizzying pace, so this is also an attempt to preserve a brief present in digital amber and leave a piece of evidence for future art historians. This is about taming the transformers, or the story of conversational investigations.
On April 13, 2022, OpenAI announced its state-of-the-art text-to-image AI called DALL-E 2. Admittedly, the published results are impressive, as it seems that it is able to visualize a broad variety of generalized concepts like in- and external structures, spatial and temporal location, style, perspective, and context. This technology is currently closed source and only accessible via a controlled demo. As of May 27, 2022, they have invited 2,127 people to try DALL-E. The fear is that this can be used for malicious purposes, misinformation, harassment, and explicit illegal content. It could have a significant economic impact on the market for stock photos, design, and illustrations. The underlying technology on which this AI relies also raises many concerns about social and cultural exclusion and bias. The amount of data needed for training is unfathomable. The electricity and computing power needed is expensive, and the impact on the environment and climate is also not negligible. Access to data and computational power required for developing and training is unevenly distributed, leaving only a few major companies dominating the research. Artificial intelligence can only work this well because it was trained on an unsupervised, undocumented, and unmanageable amount of text and image pairs from the internet. The idea is that this should be broadly representative of how different people see and describe the world, but the reality is that access to the internet is not evenly distributed. A male, white, young, and Western point of view is dominant in the training data. Minorities, unheard voices, and niches are reduced and averaged out of the equation. The promise of generative models is the potential to complement, extend, and amplify human creativity. They could democratize image creation in much the same way that photography has changed our understanding of painting. They could herald a flood that ultimately signals the end of creative scarcity and permanently change our relationship to media, its creation and reception. Ultimately, the consequences will remain in the depths of the unknown unknowns for a while, but the fact is that this technology is here to stay.
On January 14, 2022, 4 months before the announcement of DALL-E 2, I got my hands on a similar text-to-image AI called Disco Diffusion. It is a collaborative effort of many talented hackers and developers who piece together technological breadcrumbs left by OpenAI and other researchers to engineer an open-source alternative. Although still temporally close to DALL-E, this AI is more like its great-grandfather, influential but outshined by its descendants. Because this effort is not backed by multi-million-dollar companies, it depends on publicly available technology and pre-trained datasets. As a consequence, the results may not be as coherent or qualitative, but the underlying technology is comparable. To the extent that insights from these open source investigations are actually part of DALL-E's architecture.
The first image always starts with noise. Randomly assigned color values are mapped to each pixel. It's the image's Big Bang event where its starting conditions are defined. This is also why it is statistically impossible to perfectly regenerate an image by prompting alone. I do think that it is interesting to watch how the machine organizes the pixels each time step. With every iteration, the image becomes clearer. It builds up from a misty veil. The digital viewfinder focuses in slow motion. The lens opens and you start to recognize first forms. The associations thaw on the tip of your tongue. Instead of individual brushstrokes, pixel layers of minuscule color information are superimposed. There is no particular place of attention. The image simply exists as a whole and moves through its temporal axis. It takes about 30 minutes to generate an image. Modern alternatives take roughly 10 seconds. There is something fascinating about witnessing this technology at this stage. Temporal glimpses such as these are becoming even rarer as the future continues to accelerate, and a feeling hides in that thought. There is an aesthetic quality in this process that I already miss. What intrigues me most is the unique transformation process of natural language. While you can instruct a machine by writing code, the fact that you give it instructions in plain language makes it approachable. It feels natural and suspiciously easy. Natural language becomes a subtractive manufacturing tool for shaping out the computational surface of the model in search for a specific image. Paradoxically, it simultaneously becomes the material itself, since it is the substance that is actively influenced. The answer to this dichotomy lies in the embedded training data of the model. This data is the primordial material which condenses and crystallizes as the computational surface that one interacts with in the first place. At some point, I was interested in how the machine would handle vague prompts. So I asked another AI to help me create a poem by remixing sentences I found in a book about artificial intelligence. Thinking that it would evoke a collaborative spirit between me and the machine, I also added my own name as author to the prompt. I tried out different style and prompt combinations, and one thing struck me. When my own name was present, the color yellow also occurred. Sometimes it was just a shy yellow spot, other times bright orange streaks, but occasionally something tangible crystallized. I was confused and pleasantly surprised. It seemed that the algorithm associated my name with a yellow balloon.
Then, for a short moment, I felt a temptation.
I thought that this machine is somehow able to show me something new and true about myself. I imagine that it is able to attach a meaning to my name that comes from a source beyond my reach, that the yellow balloon is a symbol of my inner being, an encoded representation of who I am. I asked myself, was I so humble simply by existing that it can create these images just by invoking my name?
I could only speculate why the artificial neurons for yellow were active in these experiments. But I was intrigued. I asked the machine to only create a portrait of my name in the style of an oil painting. The first collection showed an orange background and a distorted white man in his 40s, with dark hair and beard, sometimes with shapes suggestive of glasses. When I increased the weighting on my name tenfold and repeated the process, a different crack illuminated its material. Some specific areas and shapes were still colored red, orange, and yellow, but the background was more precise and concrete. It depicted an ice hockey rink. I increased the weights up to 100, and all that crystallized were abstract, exaggerated letters, representations of an old man. But the associations with ice hockey remained.
After that, it was a waltz. So they have waltzed their way into the penalty box.
As it turns out, one of my namesakes is a Canadian ice hockey player who played for the Boston Bruins in the 1980s. This linguistic proximity may have led to a crystalline pathway faintly flashing in the depths of the program's training data. The team's jerseys, mascot and team colors were white, black, and yellow.